data science has been booming. We all know that.
Yes,
So
yes.
in data science now, there are people who do online courses, people who do PG, people who do a diploma course, and people who actually work on it, right? So the industry is having a recession because we have plenty of resources in data science now. So now the key is on how you distinguish yourself. It's not just learning the basic set of algorithms. Now it's more of how you get the crown that I am a better data scientist. So in that way, yes, jobs are difficult now for us to get. That is true. But apart from that, the regular development, software development side, I think it's having a good. I would say that people are having good jobs, and there's a lot of openings happening. But data science world is having a little bit of difference in the
Yes.
way we used to have talent acquired.
What about cybersecurity, ma'am? Is it in this
Cyber
same?
security is booming. I definitely have to say I just logged into the last 5 minutes of the session. Cyber security is booming. It is something that industries are looking into. R&D departments are opening for cyber security space, and cyber security is also again ML, right? So AI ML in the space of security, in the space of automation, in the space of reliability, health. These are all booming. So when we say health, it's not just the patient health, it's also the health of the industry, right? The instrument health. So health monitoring has become very crucial, and security is again, like, you can have it as a separate part also and as a part of health monitoring also. So these are departments which are opening into R&D, not just the regular software jobs, but we are having R&D. Because I think a lot of you might have seen that couple of banks had an attack, cyber
Yes,
attack.
yes.
And we are also now thinking on what are the softwares that we should be using, and am I safe when I am browsing. And even I have been prone to attacks, like my passwords have been hacked, and couple of times I had to reset.
Because in the Department of CSE, we have started cybersecurity course also from this year.
Okay, I think that's a great move.
That's better. See, we have 2 UG, 2 PG, and PhD also in the department.
Oh, great.
So that is the reason I just because the placements that we received in the earlier year are more than this year, actually. So
Yes.
earlier, like we have an intake of 180, we got 598 jobs at that time.
Okay.
So this time, what happened is 170 students are there. We got only 420 now, 421 exactly. So
Okay.
the number of multiple jobs are also getting reduced. The reason is just to find out whether there is a recession or the recruitment is less or something like that.
I would say the other problem is in the last 2 years, the way seasoned professionals are seeing their profession has changed. So there's a lot of switching happening. Like I myself have switched a company. The only reason is that we are looking for flexibility after the pandemic period. We are looking for flexibility. So this year, a lot of companies did not take more freshers. They actually had options of seasoned professionals switching. So that way, I think for freshers, it's been a little tough this year. But I think next year onwards, it will be back to the usual, because now the switching is almost consistent and people, it's balanced out. So I think next year it would be more on the regular seasonal recruitments would happen. This year and last year both. Last year it was good, you were saying, but even last year we had a lot of even when we take interviews, right? If we have a choice of a fresher and a choice of a seasoned professional, we try to balance one each. But earlier it used to be like 5 or 4 freshmen, yeah, and then we used to go for 1 or 2 seasoned professionals who can train them. But the last 2 years, it's been the time where you can get good talent, because people want to switch, and they're switching because they want either work from home, or they want to have a hybrid mode, 2 days office and 3 days being at home. They want a better work-life balance, so people are willing to switch.
So you are working from home.
Today, yes, I am working from home.
Because even my students, they say that 2 days they are going for office and 3 to 4 days they are staying in their home to do something like that.
Yeah, actually, I have not seen my new office. It's been more than a year. I've joined a year back, and I will be going to my office next month.
Next month. So it is
Yes.
mandatory now. It is mandatory that
Uh,
you have to go.
Yeah, they have made it now that schools, colleges, and everybody has gone back. It is time for us to go back, so I have to go back.
Is it complete or partial? Like 3 days you come, 3 days you stay, something like that is happening.
Depending on the offices, I think it is possible. Like I have a few colleagues who have a hybrid mode. 2 days they go and they decide on which 2 days they want to go. And there are a few colleagues of mine who have like taken at a stretch they'll go for 10 days and 20 days they'll not go. And I am planning to take that mode. I am going to opt for that. So some companies are giving us an option that as long as you do the work, it is fine. It doesn't matter where you stay, how you do it.
So the working culture, there is a disruption actually.
There is definitely a difference, and that might be a problem for freshers to learn, because earlier, whenever they have a doubt or something, we are always available in the office. So now they have to wait for us to be available. They have to dial in, and it's a little bit different. But I think people are getting used to it.
They have to adapt to this.
Yes. Yes.
Thank you, madam. We'll start the session now.
Yeah,
Sunil
sure.
sir, please.
Thank you, sir. Good afternoon, ma'am.
Very good afternoon.
Ma'am, we, the Department of CSC, Sri Vishnu Engineering College.
Sunil sir, better you share the screen and then we can start.
Sir, 1 minute, sir. Yeah. Good afternoon, ma'am. With the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram, we welcome you to this faculty development program. First of all, we'd like to convey our thanks for your valuable presence in the faculty development program. In spite of your busy schedule, we are here to share your valuable industry experience as well as the exposures to our participants. Before entering into the session, let me take the privilege to introduce you, ma'am. It is my great honor to introduce Dr. DrVaibhaviRajendran. Dr. DrVaibhaviRajendran, working in ANZ Operations and Technology Private Limited, Bangalore, as AI solutioner, NLP researcher, and data scientist. She worked as data scientist in ANZ full-time for 2 years, 8 months, Bangalore, Karnataka. She worked as an AI engineer in Concentro for 6 months in Bangalore. She worked as a data scientist in Global Services Limited for 1 year, 1 month in Bangalore, Karnataka. She worked as associate researcher in Vellore Institute of Technology for 3 years and 8 months in Chennai area, India. She did Doctor of Philosophy, multifarious Tamil text processing for a speech synthesizer in Vellore Institute of Technology in 2017. She received her Master of Technology in Computer Software at Rajalakshmi Engineering College in 2011. She received her Bachelor of Technology in Information Technology in 2009. She is skilled in natural language processing, artificial intelligence, and machine learning. Ma'am, really, all our participants are very happy to have an industry expert as a resource person for the academic faculty development program. Ma'am, we request you to share your valuable insights to our participants. Thank you so much.
Thank you very much for the very detailed and chronologically ordered detailings of my experience. Thank you on that. And let me quickly share my screen. Today I'm going to talk about a very simple yet very important topic that we are facing in the industry. So just let me know if you can see the screen.
Yes, ma'am.
Okay. So I think we are all used to learning machine learning. Yeah.
Ma'am, your screen is not shared.
Not shared yet. Okay. One
Yes.
second. Just let me know if you can see it now.
Yes, ma'am, it is.
Okay. Okay. So let me.
Yes, ma'am. Now it is.
Yeah, thank you. So let me start that. I think when we talk about machine learning or artificial intelligence, I think we directly go into seeing on what are the trending algorithms or what are the trending solutions which are available. Are there any inbuilt models, pre-built models? What is the latest in NLP? What is the latest in computer vision? And then we start from there when we learn. But a very less spoken topic, but which is very important in this era right now, is the data in itself. So there are a lot of ways in which we can acquire better results in the industry and as well as in academia if we focus on the data. So one of the major problems that every industry is facing now is having good quality data. So I know data is in abundance. That's why we speak about big data. We have volume. We have the data flowing in at every minute, every second. It's streaming in huge volumes. But the point is the data in a consumable manner for our algorithms? Are our ML algorithms or AI algorithms able to take the data as such and use it? Is it in a usable format? Is it in a labeled format? Is it in a readily consumable format? The answer is definitely no. So if we look at the good quality of data, the right amount of data that we have, it is very less in quantity and quality. So what are the ways in which we can actually get the algorithms to perform better or have techniques in which we get better solutions with what we have? Because in academia, at least I can go and tell my professor or I can go and tell my thesis advisor that, see, this is the issue, I'm still trying to find data, and I need 6 more months. I'm fine with it. It's my 6 months of my PhD time that I am taking and I am going to improve on. But when it comes to a client, right, you are in an industry, you are in a client, you're in a space where you are dealing with a client who wants a solution with whatever data he or she has, and that company or the organization is giving you, like, I have only 10,000 lines of data. There's no way that you can increase it, or there's no way that you can take another organization's data and append it unless and until that client agrees to it. So, and the other reason is we have certain domains where the nature of data itself is such that it is low. Like if you go for credit card fraud activities, the fraudulent activities will naturally be lesser than the other regular activities. So in that space, I cannot go and claim that, okay, if I have more data, I'll give you a better model. I cannot claim that. I should be having better ways to cope with whatever imbalance I have in the data, and proceed with that. So that is one of the main things that we are going to see today. So the importance of data is like essential. If I believe, and I've seen that if you listen to the data, you will understand the nature of the problem. You will understand on what are the issues that is there within the data that will help you, and you'll also understand the properties of the data, which will help you select a good algorithm for your problem statement, and as well as get a better performance. Like I already said, when Dr. Kiran was asking me what is the recent trend, is there a recession? So it's about how you distinguish yourself, right? So if I have a set of algorithms and I am given a data set, everybody applies the same algorithm. A sklearn is available, I just go take the code and I apply it, right? Everybody gets 50% accuracy, right? So then the point is, who's doing it better? So these are ways in which we can make our solutions better. So it's not about competing with another person, or it's not about making yourself just better. It is also about making the solutions better. So we need to understand the things on how the data was collected. Is there a problem in the way the data was collected? Is that the reason on why there is an imbalance in data? Particular, if it's a binary classification, is that the reason on why one of the classes has more number of instances compared to the other? How the data was collected, where it was collected, why it was collected? These are questions that we need to look at to understand the nature of the data. So if you listen to the data, it will definitely give you more solutions. It will definitely give you more insights about the problem that you're trying to solve. So data in its raw format and the properties of it are very important for us to assess and go forward. So like I was mentioning, if it could be a binary classification where one class is higher, the other class is lesser, or it could be a multi-class problem where you have a few classes having more data and a few of them having less data. So I cannot blindly say like, okay, either give me equal number of data for all classes, or I will minimize the data, right? In some places it will work, it might work. I'm not saying it will not work everywhere. In some places it might work. But what if the nature of data is such that these two classes are supposed to be low, and that is why my data set also has it low? Then there is no bias in the data collection method. Then the only way is like how you cope with it while developing your solution. And is it wrong if I put the data as such to the model? It's not wrong. But what the problem will be is the model will not be able to perform as good as what it performs on a class where there are additional number of instances. The model will perform really well on the instance where, let's say, we have this column which says class 2. This has more than 70 instances, right? You can consider it to be 700, 7,000, 70,000, anything. So this comparatively has a lot of instances compared to this class over here, which is class 6, having the least. So the model has not seen many instances of this particular class. So the model does not know how this particular class behaves. It does not know the usual trends. It cannot identify a good pattern out of it. So that is the problem that we are facing when we talk about imbalance in data, right? And this, I have again jotted down the points that I just mentioned, that in a binary classification data set, if one of the classes forms the majority of the data, then it constitutes to imbalanced data. So that is the right definition of what an imbalanced data set is. So I cannot say that if I have 50, it's a balanced data set. If it is, let's say, 60-40, is it imbalanced? It is definitely not imbalanced. Slightly imbalanced, but it's something that we can live with. 70-30, is it imbalanced? Really not. But so then what is the actual ratio at which we say that the data is imbalanced? It's something that's very subjective, but naturally we say anything less than 20%. 80-20 is something where there is a huge imbalance. 90-10, definitely there is an imbalance and we need to do something about it. So now what is the number when we come to a multi-class data set, right? There's no real number there, because like the example that I showed here, if you just show me these two, I'll say yes, there is an imbalance, class 1 and class 7. But if you show me class 2 and class 1, is there an imbalance? Not really, right? So in a multi-class classification problem or a multi-label classification problem, how we define an imbalance in data is very subjective. But definitely in this, I can say that these instances are very less compared to 2, 1, and 7 classes. So there is definite imbalance in data even here. But there are few options that we can use here, like combining these classes. Would that help if I put a multi-label or a multi-class? Or can I try a hierarchical classification here? So these are techniques and ways in which we make a solution better, and we don't touch exactly the data set in itself. So this today's session is all about what are the different ways in which we can creatively think of ways and solutions to deal with imbalance in data. Right. So there are 4 different places or levels at which you can give a solution. So like I said, I don't do anything later on. I know I have an imbalance in data, so at the first level I should fix it, right? I can't just select a very complicated deep learning algorithm. Then I can't just say like I will create a pipeline of ML architecture. I'll use cloud computing, I'll use big data, I'll stream my data, and I do all of the things that are trending. But I'm having an issue at the very first place where there is an entire imbalance in the data. I'm just having, let's say, 100 instances of a particular class versus, let's say, 10,000 instances of another class, right? Where it can be credit card fraud detection, or it can be something like email spam detection, or it can be some kind of an weather forecasting anomaly where I'm saying if there is going to be a huge flood in this particular season or not, or if I'm saying there's going to be an earthquake or not. So in all these cases, the nature of data in itself is in such a way that one of the classes will be lesser, right? So what am I going to do with that, right? Am I going to correct it at the data level? That is the first solution that we'll see. The second one is that I know that I cannot do anything to the data. Like I said, credit card fraud, I cannot give more instances of fraudulent activities. If it's something else like seasonal data, let's say that it's a rainy season now, and I have to build a model which tells like which actually has a data set of the last 2 months data of sales of an AC, or sales of a fridge, or sales of any electronic equipment in a household, right? And then you give me the 2 months data and you're asking me what is the sales for next summer, which is essentially April, May, and June. So is that a correct data set? Is that there will be an imbalance in the number of sales that you have on the AC units in winter and summer. It's something that all of us know logically as human beings, right? So if I just take the data set and use it, then it's wrong. So I do something at data level there. I know that the problem there is at data collection level. I can fix it. But in case of other anomaly instances that I said, like a credit card or email spam and other things, the nature is such that I cannot increase it, right? So for the cases where I know that I can increase my data, I will do something at data level. But if there are cases where I know that I cannot do something on the data level, the nature is such that then I will try to do something on metrics level. Are there any different metrics that I can use that will help me evaluate the model in a right way? Or can I do something while training the model to let the model know, like, okay, so this is a special case, treat this individual specially. There are only 5 people like this, but you have to give them VIP treatment. Can I do something like that? That is what we do during modeling. That's the third solution that we have. Or the fourth one is like, can I choose an algorithm in such a way that it will deal with a lesser amount of data on a particular class? That is how we will go ahead with the fourth solution. So these are 4 different levels on which we can actually choose a good solution, even if there is an imbalance in data. Right? So one of the, I think, very widely used, I'm sure a lot of people in the session also would be knowing, is we would be using either an oversampling or an undersampling. And the reason which I just mentioned is, if I just throw some garbage in, it is going to, the model is going to give me garbage out, right? Irrespective of whether it's a traditional, very simple naive based classifier, or I go with a very complicated deep learning BERT model, or if it's NLP, a BERT model or something, or a lambda language model or something, or if I go with computer vision where I go with ResNet or anything it is, right? Anything it is, if the data that you throw to the model is not good enough, then the model is not there to be blamed. We shouldn't be blaming the model at all. So that is what this is all about. So we know that some of the solutions that we have are either oversampling or undersampling. Like I know if class A and class B is there, class B is very less, then I will oversample it. How do I oversample it, right? I cannot just copy paste. I cannot just duplicate the data. Is that the right way, or is it a wrong way of doing? I will not say, but it's not essentially the efficient way of doing it. So if I just duplicate instances, it's not going to see different patterns. It's not going to see different properties, right? If there is a particular credit card fraudulent activity happening, or if there is an earthquake which is happening, there are certain indicators, like the weather is in a certain way, there is some tectonic movement happening, the plates underneath move, and the temperature increases, humidity increases. There is something or the other as an indicator which is relatively same. But it's not like if the temperature was 45 degree, it will remain 45 degree later on. That's not true, right? It could be varying, but it's just the range that we know that we need to pick as a pattern. So in that case, rather than just duplicating the data, we would like to synthetically generate more data. So one of the very widely taken up research areas in the industry is synthetic data generation. So the ones that I have listed here, which is SMOT, PyOD, are available implementations of it and are very easy to use. But apart from this, in the industry, we also try Monte Carlo simulation. We also try other generative algorithms. I know there are GANs when we come to computer vision, but apart from computer vision, when we go to NLP, we use a lot of domain specific knowledge to generate the data. It's not essentially rule based, but we have to bring in some kind of a subpopulation generator. So some places we also use certain generative algorithms, HMM or CRF, or which are very good in generating context based instances. So we use that. And in other places, when we know like it's numerical, it's completely numerical, and it is safe for me if I know a range. Like in the case of temperature, I know it's a range. We talk with the SMEs of a particular domain, like if it's an oil pipeline which is going on, we understand the different materials that are used, that are carried in the oil stream, which are there in the pipeline. Or if it's the banking domain, then we understand on what is the nature of the transaction, what's the limit of the transaction, what is the usual periods, and how does a transaction get approved, and if it's a NEFT or RTGS, then what are the essential logical questions that any approval manager or a maker who sees the work item actually does. We understand all of these things, and then we generate a lot of synthetic data, which becomes usable by the machine learning model. Right. So one of the ways in which we can handle the data is either by increasing the number of samples, which is oversampling, or we decrease the number of samples, which is undersampling. We would use undersampling, which is very simple, looks like simple, but when you have a huge population, eliminating the population that you don't want also needs to be strategic. You cannot just like that take 100 instances and say 100 and 100 of each and I use it. That's not a good solution, because I want to still retain the properties of this distribution, right? If I have 10,000 samples and if I'm picking 100 out of it, those 100 should be in a way that they represent this population well. So even this undersampling or oversampling, whatever it is, we need to get it in a very strategically formulated way. So for that, we sometimes use k-nearest neighbors, sometimes we use other synthetic libraries also. But this is not a topic that I'm diving in deeper, because I want to cover the different techniques that we would like to adopt. So we'll move to the next one. So this one is the metrics, like I said. So one of the ways which I mentioned here is at data level. So the second one is at metric level. So now we are going to see that I don't touch the data. The data is as such, it is 90-10 ratio or 80-20 ratio only, but I want to do something apart from creating synthetic data or deleting available data to normalize the equilibrium, but I just want to do something at metrics level. So the options at metric level are, this is the simplest option that you have, but we don't essentially go with this as the final solution in most of the cases. And I'll tell you why later. So the first thing is, the option that we have is, if you're using an quite established algorithm, which is available as an implementation in scikit-learn or sklearn, which we are all familiar of, there are certain metrics like the precision, the recall, or the F measure, which is standard when we use a classifier. And and when we use a classifier where there is an imbalanced data, you have a few options, such as like whether you want to go with a binary precision, you want to go with a weighted precision, whether you want to go with a macro precision or a micro precision. And each of the keywords that I have mentioned here can be passed as a parameter while you are evaluating the model. So it means that I do nothing to the data. I use usual pre-processing. I build a model, and when I'm evaluating the performance of the model, that is the only time when I tell that there is some imbalance. Now do the calculation accordingly, right? So when we have an imbalance in data, we usually prefer going with weighted or macro. But the other point that I mentioned is, we don't usually like this option. Why we don't like this option is because we have tried and tested all of the options that I'm mentioning here. So this one essentially is not the best one, because I am telling while calculating that give an additional preference to the class which has less number of instances, give it more marks or give it less penalization, right? But that's not the good way of doing it. It might be like your baseline model. When you're doing any experimentation, it is your baseline model, and then anything additional you do after you have synthetic data generation, or after you do some other algorithm selection, or after you creatively bring in a new R&D space there to say like, you know, we want to we want to give a solution of this with this hybrid implementation, and then we want to try this. Then all of those times this solution becomes our baseline, and with this baseline we then go ahead to build our other types of models. So this is like the least liked option, but a good way of starting if you have an imbalance in data, right? The other way is the third way, or the third way of solving when you have an imbalance in data is while training the model. So which we called as cost sensitive learning. So why we call it as a cost sensitive learning is, I am saying that there is a penalization cost that will happen to the model because I have less amount of data in one class. And that is going to cost me a lot when I'm going to have an evaluation or when I'm going to run my inference in a real-time environment. So that's why it's called a cost-sensitive model. And in this cost-sensitive model, again, if you're using standard algorithms from sklearn, there are options that you just pass a parameter while doing a hyperparameter tuning, and you will be able to use this cost-sensitive learning. But if you're having an hybrid algorithm of your own, or if you're using any of the deep learning algorithms, or if you're using a combination of them, right, where we are in a space where we are experimenting, then we will have to implement this cost sensitive learning by imbibing the way, or the way in which the weights of the instances are being calculated. And when we are formulating the weights, we bias the model in a way that it doesn't bias the low instances, or it doesn't bias the low balanced class, right? The one which has the least amount of data, the one which is ranked the last in terms of the quantity of the data, that shouldn't get biased, that shouldn't get neglected, right? In order to do that, we try to bring in a factor which will negate this bias. So that is how we try to build a cost learning model that we want. But like I said, when you're using a standard sklearn algorithm, it is very simple. There's a hyperparameter that you have in most of the models where you can just go and say, I want the class weights to be either the weight of the instances. There's a class weight calculator that you have in sklearn which you can pass, or you can just say class weights to balanced, or class weights to subsample, or class weights to sample, and it will do the work. So that is the other easiest option that you have. And the other option is like if you're going in for neural networks, then specifically you will not have class weights. You will be having sample weights, or even in terms of when you go for a regression, you will not be having a class weight option, you will be having a sample weight option. So for the sample weight option, again, it is easily available in sklearn. We don't pass it as a hyperparameter while tuning the model, but we pass it as a parameter while fitting the data to the model. While we tell the data to learn about the pre-processed data set that we have, that time we tell that, okay, for these instances, you need to calculate the weights in a different way. So we bias it, or we say we negate the bias by adding in the sample weights during fitting the model. So these are again other two simple options that are available in sklearn. Like I said, if you're going to go with more complicated algorithms, we will have to do our own in-house implementation of these. And in some of the algorithms, the good news is you can actually explore a combination of both. Some algorithms will have only class weight. Some algorithms will only have sample weights. Some algorithms will let you do both. Like I think neural networks will not let you do class weights. It will let you do sample weights. But if you take an algorithm like random forest, it will let you do both. So there are different combinations of what weight you can use as per the selection of your algorithm, and you can try out that you will be able to get at least 5% of difference in the training that you have. So let's say that in a case study or in some example experimentation, the client says that I am good if I have a model which gives me 70% accuracy, right? And I'm down at say 65 or 66, and at that time when I use this hyperparameters and I use it with a combination of the metrics, or I use it with a combination of the synthetic data generation, then I am able to move up the number at least by 5 to 6 points. So it's a good way of increasing the efficiency of your model, the performance of your model. And going up by 5 or 6 is not usually possible if you do not choose the right hyperparameters. Everybody knows that hyperparameter tuning needs to be done, but we just put it in a grid search and we just wait until that grid search completes on what is the best parameter that a particular model gives us. But knowing on what is the hyperparameter that you need to tune to get maximum results is also a way in which you can distinguish yourself, and is also a way in which you can bring more likable solutions, more efficient solutions, right? I think I have done this explanation in the previous slide. So I have told on the option 1 is class weight, where you can pass balanced as the keyword or sample as the keyword. And the second, sample weights, is while you fit the model, you need to use sample weight as a parameter when you fit it, or when you pass it in the parameter, it does the fitment using the sample weights for you in sklearn. Right. Okay, so the last way that I want to say is that using the choice of an algorithm, right? So I think I've been repeating a few points like, is the nature of data constituting to the imbalance in the data set, or is it the collection, the data collection method, which is constituting to the imbalance in data? That's a very important question. So if it is the first, right, the nature of data is constituting to the imbalance, nobody can do anything. You can, even if you collect it 10 more times, you collect it with different techniques, it is going to be still imbalanced, right? Like earthquake or credit card fraudulent system, or an anomaly detection of cancer and versus non-cancerous patients, anything else, anything where there is a high imbalance because of the nature itself, because it's an anomaly, it's an irregular activity which is not supposed to happen in a regular manner, then we also need to do a good choice of algorithm, which is not the traditional ones. We have to go for a class of algorithm which we call the anomaly detection algorithm, right? So that is what I'm trying to mention here. The other way of handling the imbalance is by selecting an algorithm which is designed to deal with this kind of data. And it is sometimes the nature of the phenomenon that should be considered while you select the data, or while you select the algorithm. So there are a few algorithms which help us when there is an imbalance in data. One of the classes of the algorithms are called anomaly detection. The other is called outlier detection, right? So we'll see in detail about them. So it is an normal activity versus abnormal activity. It's a regular activity versus an irregular activity. And that is why it's called as an anomaly detection. And some of the examples which I have been mentioning are like in an intrusion detection. There's not an invader always, there's not a cybersecurity attack always, there's not a fraud activity happening always. It happens at times, but we need to be prepared for that at times. We can't say that the data is less, I can't train it, the data is less, so I can't do anything about it, I'll just wait for it to happen. Is not something that the industry can handle, or anyone can handle. If the industry is handling it, it means that my mobile phones are more susceptible to attacks, my laptop is more susceptible to attacks, and all of us are going to be in a panic state. So it means that even in cases where we have less data, we need to do some or the other implementation of what we have been speaking now to get some solutions that will help us. So event detections or ecosystem disturbances, these are all places where we will have definitely less data. So some of the approaches that we have in anomaly detection are, you can either go for a statistical approach, like where we have the quantile information, the population information, the probability density function, and then you can try to draw out solutions based on the mean, median, or moving average techniques and other things. The other ones are the usual supervised techniques that we mentioned about, and some semi-supervised techniques and unsupervised techniques. So we'll see a few of them in example. So the first one here is a statistical technique, which I just said that a usual box plot or an outlier detection using the median can be done once we know the quantile information. But although this is the simplest, easiest, and the very early drawn methods for anomaly detection, essentially not the best. The reason is, once you give it a subset, or once you give it a population, right, it deals only with that. But what is a major difficulty here is that already the population is less, right? So if let's say I have 1 lakh or 1 million instances, then I use this quantile distribution method. Okay, right? I'm at least covering a huge population, and I can be like, fine, it will take care of it when the actual instance happens. But my population itself is very limited. It's a very small number. So will this help me there? Not essentially, right? That's why we want to go ahead with more intelligent ways, or more ways where we can actually deal with such anomaly detection techniques. Some of them are isolation forest, which we know gives an anomaly score, and this is easily available in different packages. And one of them is clustering, right? When we say unsupervised, right, I don't have any tagging. Nobody is there to tell me like, yeah, this is fraudulent, this is not fraudulent. Then in that case, I think we can go with clustering. And if you want to know about another supervised technique, unsupervised technique, autoencoders are there. This has been like in the last 5 years, something that most of the industries have been adapting to. Even I have used it a few times in our solutions, because it helps you when there is no labeling available. And it's actually a quite generic solution that you can apply in multiple places. So autoencoders is one of the unsupervised solutions. And the other one that we have here, which is quite colorful, and I put some layers here, is the combination of this autoencoder, which is neural network, plus clustering that we spoke here, right? So together, there is something called as organizing maps. So this is a combination of clustering plus neural network, which is also another unsupervised technique, which helps in detecting anomalies. And apart from this, the well-known one class SVM, right? That is also one of the efficient ways in which you can deal with when you have less amount of data, right? So all of us know what an unsupervised classification is, or an unsupervised technique is. When you don't have the distinguisher or the distinction, the marker is not there that this is your class A, class B, or this is the class of interest, this is something that's an irregular activity. We do not know that. We just have data. We have a lot of data that's coming from a bank, where they say like, these are the transactions that happened. Now, can you help me pick the transactions which had anything of concern? It could be a credit card fraud, or it could be like someone is drawing additional to what usual their pattern is. And I think some of you would have observed that these days, if you make a transaction which is quite higher from what your pattern is, you get a call from your relationship manager in the bank. They ask you like, is that you? Do we need to approve it, or do you think you want to raise an alarm? So there are certain algorithms, or there are certain techniques which have been applied nowadays in banks to safeguard the transactions that we do. And if there's anything that comes as a red flag, it doesn't essentially stop the transaction. Depends, like if the bank tells us to stop, we can stop. We have the authority using the bank. There are cybersecurity attacks, and if we feel like it should be a security mechanism that they want to, then we give a solution where we can flag it and stop it. Or they say like, no, let it proceed, but give me a flag alone. That also is possible. So in those cases, it is just a set of transactions that you have. But since we do not know the percentage of the accuracy, or the percentage at which the algorithm performs well, we only flag it and leave it now. Right? But going forward with more research in the space of imbalanced data, we should be in a place where we can flag it and stop the transaction also. Right? So this unsupervised anomaly detection is essentially an introduction to that. So the self-organizing map is one of the unsupervised techniques that we have been adapting to lately, or I would say it's been there for a long time, but it is just that since there is no standard implementation of it, people have not used it as much as the other neural network forms that we have. But it's a really good option because it helps you do dimensionality reduction with the help of manifold learning. So I would like to mention on what manifold learning is before we move on to the other well-known genres in which it falls into, which is data mining, clustering, and neural network. So we have all heard of supervised learning and unsupervised learning, but there's something called as manifold learning, right? So manifold learning is when you have a data set which is very high in dimensions, and I want to reduce the dimensions so that I will be able to understand the properties of the data and choose the right algorithm for it. But if it's very high in dimension, how do I visualize it? How do I understand it? That's the biggest problem, right? If I have a 2D data, I will have a 2D plot. If I have just one dimensional data, I will again do some plotting, or I have a 3D data, I will do a 3D plot. But what happens if a fourth dimension comes in? So I have, let's say, temperature, I have humidity, and I have the moisture level. I plot it. But in addition to this, I then come and give you like some azimuth or some angle or some inclination or some elevation of that particular area, right? As an ecosystem detector, I give that as an additional factor. How will you visualize it? If we cannot visualize it, it is difficult to plot, and it is even difficult for our imagination to keep looking at each of the data instances, right? If you tell me one data instance, yes, I can visualize, okay, this is possible. If I'm an SME in that domain, I can do it. But when you have thousands of data points and I want to plot, or I want to visualize, or I want to understand the data which is having more than 4+ dimensions, then how do I do it? The answer to that is what we call as manifold learning. So there are many folds to the data which I want to visualize, but I cannot do it at a more than 4D space. So the algorithms that are available in manifold learning, some of them are self-organization maps. The other one is a TSNE, which we are all familiar with, and there's also something called as UMAP, Uniform Manifold Learning, right? So these algorithms, they help you to actually plot the data in a higher dimension, then reduce it back to either a 2D or a 3D space in a topological structure, in a graph, or in a connected directed graph, and then they project it to you. So the moment you look at the data, you will be able to see that, okay, this is a region that something interesting is going on. They're all connected to each other. Something is going on here. Or this is the region where I don't see connections happening. So looks like it's not something where there are relevant features or where they are interacting with each other. So I will isolate it from my data set, right? So self-organization organization map is a very good manifold learning technique, which helps you reduce the dimension and also visualize the data in a higher dimension if you want to, right? So I want to emphasize that because manifold learning is not one of the well-known or not one of the widely adapted techniques, but it's a very efficient way again. So let's learn a little bit more about self-organizing maps. So it's an unsupervised neural network technique, which has a combination of clustering plus neural networks in it. And it is only a feed-forward neural network. You cannot have a backward propagation here. And the selection of neurons are in such a way that it will form a rectangular array, right? So your dimensions or the number that you pick would be in such a manner that it will form a rectangular array. And the input to the SOM or the self-organizing map is in such a way that the because it's an unsupervised one, right? So we do not know if a regular and an anomalous data point is sitting next to each other. We have no idea of knowing it. So the technique with which SOM works is it selects any one of the points in random, and then it rearranges itself in a way that it keeps moving towards the similar points. So how similar the input is, with respect to that, the weights will get reassigned each time the iteration happens. And the most similar points will be moving towards each other, and they will be declared as the winner. So if there is a region that is colored differently, and there's one point on it which is being prominently shown, then that is your center point. And that is your winner, and that is your point of anomalous region that you need to look at. right? That's how a self-organization map works, and that's why it is named so. It organizes or reorganizes itself until it forms a group of known or regular and irregular activities, or any two classes of data points that you have. So in a gist, it does an initialization first of the weights of the neurons in the map, and then it does a competitive rearrangement, selects one input sample and then searches for the best matching unit to it, and then rearranges it. And then it does the um, best matching unit neighborhood function calculation is done to see if in the nearest proximity, let's say like if I choose the proximity neurons to be 5 or 7 or some number, that number would be since it's similar to clustering, right, we can choose the number, and that number would be used to calculate the proximity neurons, and if they are closest to the matching unit that you have in hand, or it should be moved farther. So that would be done in the cooperative process, and then based on that, the shifting of the weights and the values will be done for us to obtain the final map that we want, right? So like I mentioned, some of the advantages is that it can help us work in high dimensional data sets, which is very difficult if you cannot visualize the data set. So SOM helps you in that region. It helps you reduce the information. SOM reduces the information while preserving it. Like for an example, if I did not know which dimension is essential, I might end up dropping a feature which is essential to me. But when I use SOM, since it's able to retain the effective features by helping me visualize and by helping me understand the high dimensional interactions, it is benefiting by preserving the most important topological relationships. And it is an unsupervised technique, so I don't have to worry about labeling, and that is a major concern when we work in industry. There's no tagged readily available Kaggle data set or no UCI repository data set, or there's nothing that's available in a CSV format, right? It's all a myth that we have everything readily available, but we do not have anything which is readily available, and there's no prior knowledge of what is what. So in such cases, unsupervised learning is a definite rescuer for most of us, and it's also very efficient in handling large data sets. And even if the data set has noise, then it is a technique where it is going to rearrange similar points together. So if you review the points, you would be able to identify the noise from the irregular and anomalous activities. Excuse me. And the last, like I said, it helps you reveal a lot of correlations. So it's a very good and effective technique. But the disadvantage is that it's clustering. You need to mention the clusters. You need to do some trial and error, or you need to know the domain for you to get the right number of clusters. And the other problem or the other concern is there's no standard implementation. Some places you will have to do some tweaks here and there for you to get a good implementation. And there are some TensorFlow and Mini-SOM package combinations if you use together, which can help you get a SOM implementation of your own also, right? So I think I would be summing up the imbalanced data problem with that. If you have any questions, I would be happy to take it up.
Thank you so much, ma'am, for giving a very detailed presentation about what are the problems in the data. First, we'll go with the audience. Participants, if at all you have queries, please unmute yourself and ask. Dr. DrVaibhaviRajendran is ready to answer.
Good afternoon, ma'am.
Very good afternoon.
Madam, that's a good one, ma'am. Actually, your presentation has solved more doubts regarding this data, madam. But I'm a MTech student. I'm doing my project work. My data set, it is a huge data set. I want to detect or predict the autism or ADHD diagnosed diagnosed children, or depending upon the age, I want to diagnose the ADHD and autism patients, madam. And the data set, it has a huge number of columns and rows, madam. It is in around, the columns are around 800 and the instances is around 10,000, ma'am. Am I audible, ma'am?
Yes, yes, I can hear. Please go ahead.
The data set is a very generalized data set, ma'am. It has an age and the sex, and also what are all the health conditions, the financial conditions of each person or patient as listed in the data.
Okay.
It is a statistical data, ma'am. I want to concentrate only on the fields that are related to this autism and ADHD, and I'm unable to select which feature is more important, or which feature affect these target variables, that is this autism and ADHD.
Okay.
So how to I thought to correlate each and every feature to one another, and the correlation matrix is around 800 by 800, so I can't even see which feature is more important. So how to do with problem?
Okay, I understand. I think this is one of the reasons why I was mentioning that manifold learning is the answer to your question. So I know that 800 cross 800 correlation matrix is difficult. Even if you use any other techniques, like where you're going to do a PCA or a transformation and then reduce 800 directly, it's not going to help. Reason is 800 as such are not all the features that your model needs. And your model cannot survive if you put all 800 features inside also. It's not a good thing to do. You need to reduce your dimensions. So general dimensional reduction techniques may not be helpful. You can use some methods like uniform manifold approximation projection algorithm. It's called UMAP. That's an algorithm which is available. Or you can use the SOM, self-organization maps algorithm, to help you reduce the dimension. So you can actually view the projection, or you can see on how one feature interacts with the other. So that way you'll be able to reduce your dimensions. Other few techniques I would say is you need to do a distribution map. There is some disturbance. I'm not sure if I'm audible. So you will have.
Are there?
You are audible.
Okay. So you need to do a distribution map. Like some techniques that we do is, you have to, we deal this a lot in industry, right? Because it's just, we are gonna entire dump, and you need to segregate and somehow come down to say 30-40 usable features. 30-40 itself is high, but from 800 or 1000 or 2000, we usually have to come down to some set of features which is at least readable in a matrix format, or in some format it is readable, right? We need to come down to that. So you can go with manifold learning techniques, and that is a very useful one. You have some tutorials which are very elaborate on how to use them. So use one of them and it will help you.
Okay, thank you, ma'am. Using this manifold techniques, can we reduce the number of features to around in tens, ma'am, a 10 size?
Yes, you can reduce. The number is up to you. You want 10, you want 20, you want 30, 40, that is up to you. Because it's not like I can fix the 10 is the best number of features that I have, right? It is depending on the data set that you have, and depending on what information each feature gives you. So you can choose, like if there are constants, you can remove it. If there are things that are naturally known, like if you have something where you know that female children or male children have a higher tendency of autism, then you can keep the column. Otherwise, domain specific columns also you can remove. Or if there is a region, right? Region might not be that necessarily, like it's not like people from North India or South India or region in the India doesn't say that ADHD increases or decreases, right? So if your data set has such columns, you can remove them just with domain knowledge. So just sit down with a domain expert, you can remove them, or just logically think them through and remove. But apart from that, when you do that level, you'll be able to remove say 5 or 10 columns only. The next level of columns you'll have to remove using constants. Like if some column is always constant, it rarely has a different value, then you can remove it. It's not going to give much of a weightage when you actually train your model. Then the next level you have to see is like after you have done this, just try to select the top 20-30 features and put them through a forward and a backward random forest regressor or a random forest importance feature selection or a permutation feature selection, right? Just select top 30, 40 and then put it. And then you see the important level that you get. Or the other few packages also you have right now, like SHAP, which is called Shapely or SHAP. So you can use that package to see what are the important features that you have. And manifold learning, like I said, if you have 800 dimensions also, it will actually create a mapping in the 800 dimension, then reduce it back. Okay. When it reduces it back and projects in 2D space, when you hover over each, you can actually have an interactive plot. And if you, let's say, have 1 million data points also, you will have a very closely knit 1 million points projected in the plot. And when you hover over each of them, you will know like what is the one that is connecting them to each other. So there are a lot of options available in manifold learning, but sometimes you will have to tweak the implementation, write your own code. That's the only catch there, but you have a lot of options available in manifold learning. You can try them.
Thank you. Thank you so much, ma'am. That's very helpful. Thank you.
Thank you, Madam Vaibhavi. Thank you for joining and sharing your valuable insights.
I am honored. I think this is the second time you have given me an opportunity, and I am honored and happy to be here.
Really, it's our privilege, madam, actually, to have you. I think in 2020 we had you in FDP. Is it right?
Yeah. Yeah.
So there is a gap of 1 year.
Yeah.
Thank you so much, ma'am. This was really very informative session and helped us out actually how to handle the data. So it's really very good.
Participants' response now.
And we enjoyed your session very. Like I took all the screenshots of your PPT and it is really going to help us.
Okay, I'm happy. Last time I had shared the PPT, but this time this is my company proprietary right. So this time I won't be able to share it.
Anyway,
but
we will share your video because it is recorded now. So obviously that can be shared.
Yeah, that would help the participants.
Yes. Thank you very much, ma'am. Have a nice day.
Sorry, sir. Ma'am, how can we contact you in future if we like want to get some help or some like
you can look me up in LinkedIn. I am very active in LinkedIn. You can just look up for Dr. DrVaibhaviRajendran, just my name, and you will get my profile. Or I think my mail ID is available with sir. Yes. You can get it from him.
I will share your mail ID.
Okay. Thank you so much.
Thank you, madam. Have a nice day.
Thank you all.
Thank you.